Hello and welcome along to another video with Mr. Burns. Today we are going to look at number bases. It will be a short introduction to this, looking at a few different number bases and blending this into algebra. Okay, you should know your decimal number system, right? Whether you have been working in primary with decimals and secondary with scientific notation, and then further up the school you'll be looking at logarithms in base 10. This here is known as the base. This here is known as the exponent. We're going to look at initially base 10. This is the one everyone is familiar with. Column headings: thousands, hundreds, tens, or ones, which we'll denote as a U for units, tenths, hundredths, and thousandths. 1,000, 100, 10, and our ones column, our tenths column, hundredths column, thousandths column. In terms of base and exponent, 10 times 10 times 10, 10 cubed. 10 times 10, square number, 10 squared. Okay, 3, 2, 10 to the power of 1. 3, 2, 1, 0. What does then that mean at the right hand side of the decimal point? 3, 2, 1, 0. 10 to the power of negative 1. 10 to the power of negative 2. 10 to the power of negative 3. Okay, let's look at a number then. Let's look at 169. Okay, so 100 and 60, so 6 tens, and 9 ones. Okay, right, so 169. So 169 also looks like this. 1 times 10 to the power of 2 plus 6 times 10 to the power of 1 plus 9 times 10 to the power of 0. Now we could continue this on with different bases. If we went into base 2, say, then we would have the base would change. Okay, so we would have, instead of 10 cubed, we would have 2 cubed, 2 squared, 2 to the power of 1, 2 to the power of 0. Now notice how in this column here, it's still a ones column. Okay, 2 cubed is 8, 2 squared is 4, 2 to the power of 1 is 2, and that's still our ones column. 2 to the power of negative 1, 2 to the power of negative 2, so base 2, exponent negative 3. So what would that look like? 10 to the power of negative 1 is 1/10. So this is a tenths column. This is a half column and a quarter and our eighths. Okay, and we could do the same for, say, base 5, 5 cubed, 5 squared, 5 to the power of 1, 5 to the power of 0. Still in our ones column. We'll do more of that in another video. I want to blend this here into algebra. Algebra is described as a generalisation of number work. I've got another video that's on the vocabulary. Let's generalise this, because if that was base 10, then we've got 10 here. If that was base 2, we've got 2 here. If that was base 5, we've got 5 here. 5, base 5, exponent, any number in the real number line. Let's generalise it. X cubed, x squared, x to the power of 1, x to the power of 0, x to the power of negative 1, x to the power of negative 2, x to the power of negative 3. This is our ones column. X is x, x squared is x squared, x cubed is x cubed. Decimal point's a decimal point, it never moves, it's always in the same place. 1 over x, 1 over x squared, 1 over x cubed. Now if you've completed what I'm doing currently National 5, you'll see a lot of these rules where anything to the power of 0 is equal to 1, but really algebra is a generalisation of number work. So if we were to write 169 in base x, 1, think about this as our, if we were in our base 10, our decimal number system, that 1 would represent 100. Right, this is our squared 1, 6, 9. Okay, so what would that represent looking at this here? 1 times x squared plus 6 times x to the 1 plus 9 times x to the 0. Okay, so we've got 1x squared, which is an x squared. We've got 6x, and we've got 9 ones. Now at National 5, you're expected to do lots of things with this. Okay, you should be able to see a relationship. You maybe think about why I've chosen that particular number if I've not already said so in the video. Why have I chose this particular type of number, right? What can we do with this expression? Okay, it's an algebraic expression, right? It becomes an equation when there's an equal sign. If we were to put then an equal sign there, what else at National 5 or indeed higher would you be expected to do, right? You have to have a grasp, a grasp of number work before you then go into your algebra. Okay, thanks for watching.